Solution to example 8C from note 6.4, day 3 on graphing sine and cosine. So we're going to graph this by incorporating all the transformations at once. First, we're going to notice that we have a coefficient, the b value, that's something other than 1. So we have a 3x here. So we're going to want to factor out that 3 to isolate the horizontal dilation from the shift. So I'm going to factor out a 3, which is going to leave me as y equals cosine 3 times the quantity x minus pi over 3 plus 2. Okay, now let's do our analysis. The first thing we want to know is the axis of oscillation. Okay, in this case, this graph has been shifted up 2, so this plus 2 here means that the axis of oscillation is going to be the horizontal line y equals 2. Make sure you put a vertical scale on your graph. So I'm going to put that on my graph, and I'm going to draw the line y equals 2. I'm going to sketch that in as a dashed line because it's not really part of my graph. It's just going to help me draw my graph. So this is y equals 2. This is my axis of oscillation. Next thing that we're going to find is the amplitude. So the amplitude is, in this case, that would be the vertical stretch factor, which is 1. So this graph is actually going to just move up 1 and down 1 from the axis of oscillation. So I'm going to sketch in the maximum and minimum line, or dot in the range for my graph. The next thing that we're going to want to find is the period. The period for any sine or cosine graph is 2 pi over b. That'll come for the horizontal dilation. 2 pi over 1, b is 3. So 2 pi over 3 is our period. And we'd like to know the intervals at which the key points occur. So key points occur at intervals of the period divided by 4. So in this case, that's going to be 2 pi over 3 times 1/4. So that's 2 pi over 12. I'm going to simplify that to be pi over 6. So key points are going to occur every pi over 6. That's going to help me set the scale on the x-axis. And the last thing, I need to find a point so that I know where to start. So my starting point for this graph, normally for a cosine x, it would be at 0, 1, because cosine starts at a maximum. And now we're going to apply the transformations. So the transformations that are occurring to x in this graph is, first we're going to have to multiply x by 1/3 because of this 3, and then it's going to be shifted right pi over 3, so we're going to add pi over 3. So accounting for these two transformations, let me fix this, this will be pi over 3. We would have, our new point would be the x times 0 times 1/3 is still 0, so 0, 1, and 0 plus pi over 3 is pi over 3, 1. And then let's put the transformations for y. So what's happening to y here, the only thing, we don't have a vertical stretch, so we have a shift up. So onto y, we're going to add 2, so plus 2. So our starting point, 0, 1, is transformed to pi over 3, 3. I'm going to go ahead and plot that point, but I need to put on my x scale. Remember, I'd like to set up my x scale with intervals of pi over 6. So I'm going to let each square be pi over 6. You could let 2 squares be pi over 6, and I'm going to count by pi over 6. So pi over 6, the next one is 2 pi over 6, which I'll simplify to pi over 3. The next one would be 3 pi over 6. That simplifies to pi over 2. The next one would be 4 pi over 6, which is 2 pi over 3. The next one is 5 pi over 6, which can't be simplified. Next one is 6 pi over 6, which is pi. And I'll put some in the negative direction. So negative pi over 6, negative pi over 3, negative pi over 2, etc. And now I'm going to go ahead and plot this graph. So I'm going to start at pi over 3, 3. So pi over 3, 3, that's maximum value. That's where we expect cosine to start. And then every pi over 6, so every pi over 6 is every square, the way I've drawn this. I'm going to go from a maximum to the midline, and then from the midline to the minimum. And I'm going to continue on with this pattern, plotting all of the key points at intervals of pi over 6. So I'll plot a few more of these. And then I'll connect them with a nice smooth curve. And we'd like to try to graph at least 2 cycles. And so this is our graph. Make sure you put arrows on each of the ends to show that the graph continues.